Okay, welcome back. Now, today let's talk about evaluating real-world exponential growth. Okay, so based on real-world data. Okay, so let's take, for example, the population of India. So we know that, so let's say we know that in 2013 the population of India was 1.25 billion, and with a growth rate of 1.2% per year. Okay, so that's an annual growth rate, and so our function would be this. So f of x would equal, so this is the, let's say we want to model the growth, the population of India since 2000, starting with 2013. So the initial value, or the initial population, would be 1.25. That's going to be our A. And then we have what? We have our growth rate, our base, which is going to incorporate our growth rate, which is going to be 1.012. Okay? Or again, it's based on the initial population. So we're going to take this, and we're growing by this amount, but this is raised to the x power, where x represents the number of years since 2013. So you can think about this growth rate as 1 plus the growth rate, which is 1.2% or 0.012. Okay, so 1 plus the growth rate, just so you know what, you can see that. Okay, so now this would be the exponential model. Okay, and so we could use this to kind of estimate or predict what the population is going to be in 2031. Okay, so again, we could look at this as t. So instead of x, which is more general, let's say this is t for years. So t is the number of years. And so let's say we want to know, hey, what's this going to look like in 2031? Okay, so how many years since 2013? Well, that's going to be 18. That means t equals 18 years, because 2031 is 18 years from 2013. And so all we have to do then is plug in f of 18, right? Plug in 18, and so this is going to be 1.25 times 1.012 raised to the 18th power. And again, if we want to round this to the nearest 1,000, and again, remember, this is in billions, right? So we want to do the nearest, let's see here, we want to the nearest, okay, so let's do the nearest 1,000th. So the so we want to go out to 3 decimal places. Okay, so in order to estimate at the 3 decimal places the population. Okay, now, so when we plug this into your calculator, what do we get? We get approximately 1.549. Now, again, remember, this answer is in billions. So, what can we say? Well, this is approximately 1.549 billion people. Okay, so that is the predicted value, or the estimated value. Okay, let's do another one. Let's say the population of China was about 1.39 billion in 2013. And they have a growth rate of what? It says here 0.6%. So their growth rate is 0.6%. Oops. So that's going to give us a decimal of 0.006, right? So now what would this model look like then? Well, it's going to be an initial value of 1.39 billion, right? So this is in the billions. And then it's going to be 1.006 raised to the t. And so now what if we want to predict the population of China in, well, let's see, 2031. Yeah, let's do that, 2031. So again, this is going to be 39, and this is going to be 0.06. And so what do we get when we plug this into our calculator? Give me 1 second, because I don't have this handy. Okay, so it's going to be okay, so it'd be 1.548. Okay, so very, very, very close to the same as India. So India's population is growing much faster. So basically, India's population will surpass, it looks like, surpass China's population by 2031. Okay, and that's it. See you next time.